Numbers can be fascinating. Ever since we start to learn about numbers as a kid, an interesting question always comes up in our minds. What is the biggest number? And most people will tell you it's infinity. But infinity is not the biggest number. Actually, infinity is not even a number. It is an idea that means something which goes on forever, something which has no end. So, what exactly is the biggest number? Well, there is no answer to this question since you can always add 120 number which is being claimed as the largest. So, what if I rephrase my question to this? What is the biggest number we know of? Now, this makes a bit more sense. And this question actually has an answer. But to understand the largest numbers we know of, we need to get a sense of scale so that we can visualize the numbers we are talking about, and that is why we have to start with some smaller numbers and then move upwards. Let's start with a not so big, not so small number, which is a million. A million is a 1 followed by 6 zeros, also written as 10 to the power of 6. It would take you 12 days to count to a million. Now, a million is used quite often in our daily lives. We buy properties in millions, the population of cities is measured in millions, etc. But to get a quick look of how big a million looks right now, just get your eyes very close to your laptop. You will see very small square-shaped pixels. Count each one of them on your screen and you will end up with a million. Because a display resolution of 1280 by 800 pixels equals a million pixels. So you have a million pixels right in front of your eyes. But a million isn't that big when you compare it to a billion. As I said, counting a million would take you 12 days, but counting up to a billion would take you 32 years. That is how huge a billion is when compared to a million. But even a billion is not that hard to imagine and is still used commonly. For example, the world population is 7.4 billion, or the net worth of Bill Gates is $83.7 billion US. Next comes a trillion. A trillion is a 1 followed by 12 zeros, and counting up to a trillion would take you more than 32,000 years. Now, a trillion is far less used than a million or a billion, but it is still used in matters of economy, like the national debt of United States is $18 trillion, and who can forget that famous $100 trillion note in Zimbabwe which happened due to hyperinflation. But a trillion is not larger than a quadrillion. Now, most of you may not have heard about numbers after a trillion because these numbers are rarely used in our day-to-day lives and have a very limited use. So, a quadrillion is a 10 to the power of 15. Now, what use can a quadrillion have? It is the number of ants on the surface of the earth. A quintillion, which comes after a quadrillion, is the number of atoms present in a single grain of salt. It is also the total number of sand grains on all the beaches on earth. It is a massive, massive number. But it is dwarfed by an octillion, a number that has 27 zeros in it. A human body has 7 octillion atoms in it. Now we take a big leap on the number line, and from 10 to the power of 27 we reach to the number 10 to the power of 80. This number is quite significant and also quite huge. 10 to the power of 80, which is this big when written down, is the total number of atoms in the whole observable universe. And remember, just a single human body has more atoms in it than the number of sand grains on earth. So just imagine how many atoms would be there in the entire universe. That number is 10 to the power of 80. All these numbers are insanely big, but they are still very small. These numbers were just an introduction. They are nothing when compared to the numbers we will be talking about in the next few more minutes. The real large numbers begin now. A Google, a name which sounds more than familiar to everyone thanks to the search engine we use every day, which is actually a misspelling of this enormous number. A Google is written as 10 to the power of 100 and has 100 zeros in it. Now, it is very tough to find a use of this number because even if you count the number of atoms in the whole universe, it would be less than a Google. Even if you filled the whole observable universe with sand grains and count the number of sand grains, the number would be still less than a Google. So where can this number be used? We need to find an application to this number, otherwise it is useless. Well, a Google can be beaten by a 6x6x6 Rubik's Cube, which has a total number of 1.57 into 10 to the power of 116 possible ways of arrangement. That number is bigger than a Google. Some more scrolling on the right side of the number line brings us to this number, 10 to the power of 185. Now this number is so big, let me explain it in this way. You have to take a Planck's length. Now a Planck's length is the smallest length in which the laws of physics work. It is ridiculously small. It is 10 to the power of minus 35 meters, which means it is a septillion times smaller than an atom. Now take this Planck's length and fill the whole universe with it. The number of Planck's length which can fit in the entire universe is 4 into 10 to the power of 185. So we have taken the smallest possible length in the universe and filled the whole universe with it, and ended up with this number which has 185 zeros in it. So anything bigger than this number can't be explained in physical terms. But we have to search for even bigger numbers. Now getting back to a Google, which is 10 to the power of 100, what if I make it 10 to the power of 10 to the power of 100? Then it becomes 10 to the power of Google, since 10 to the power of 100 is already a Google. This number is called a Googleplex. A Googleplex will have a Google zeros in it since its power is Google. But as I said earlier, the number of atoms in the observable universe is less than a Google. So what does that mean? It means that there isn't enough space in the universe to even write this number, since Googleplex has more digits than there are atoms in the observable universe. At this point, we are talking about numbers which are incomprehensible. Numbers too big to be even written down. Moving on, similar to a Googleplex, we have a Googleplexion, which is a 10 to the power of 10 to the power of 10 to the power of 100, which means it is 10 to the power of Googleplex. In Googleplexion, there are so many digits in the power itself that it can't be written due to the lack of space in the observable universe. Since we can't even denote the number of powers in this number, forget about writing the actual number and don't even think of understanding a Googleplexion. It is just too big to be understood by the human brain. But is Googleplexion the largest number we know of? No, they are still big numbers our mathematicians have thought of. The next number we will be discussing is called the Graham's number. This number is just too hard to explain, so please bear with me. Graham's number is named after Ronald Graham, an American mathematician, and he coined this number as an upper bound solution to the problem written on your screen. Now, this problem is too complex to be explained right now, so I will just rather explain the Graham's number. In Graham's number, we use an arrow notation instead of a power notation, and this changes a few things. For example, 3 arrow 3 means 3 cube, which is 27. Simple, right? But if we take 3 arrow 3, it means 3 to the power of 3 to the power of 3, which gives us 7.6 trillion. You see, just by adding one single arrow, we jumped from 27 to 7.6 trillion. Similarly, 3 arrow 3 gives us 3 double arrow 3. Now this number is 3 to the power of 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 3 and so on for 7.6 trillion times. Just 3 to the power of 3 to the power of 3 gave us 7.6 trillion. So just imagine what the answer would be if there are 7.6 trillion stacks of power above 3. Similarly, find 3 arrow 3. Keep in mind that just adding one arrow is escalating things crazily, so this new number 3 arrow 3 is way bigger than what you can ever imagine. But we are still nowhere near to Graham's number. So take this 3 4 arrows 3 and name it as G1. Okay, I hope you're still with me. Now to find G2, you have to take 2 3s and have G1 arrows in between them. Remember that G1 is an extremely massive number which we can't even calculate, and now we are going to have that many number of arrows between the 2 3s to get G2. Also remember that we can't understand the answer of 3 triple arrow trees, so when you have G1 arrows in between the trees, it's gonna be gigantic. Now in the same way, find G3 by placing G2 arrows between the trees. Repeat this process until you get G64, which will have G63 number of arrows in it. This G64 is the Graham's number. This number is so massive, so enormous, so gigantic, so humongous, so colossal that I have run out of adjectives to describe this number. Our human brain can't imagine such a huge number. We do not even know the first digit of this number, although we know the last 500 digits. But even though Graham's number is so big, so huge, there are still an infinite numbers bigger than a Graham's number. We are still basically at the same distance from infinity as any other number. At this point, my brain really hurts talking about these numbers, but moving on, the last number we will be talking about in this video is Rayos number. Now, before talking about Rayos number, I have to tell you that I have left many other large numbers in the way, like the 3, which is much larger than a Graham's number, as well as other large numbers like Skew's number and Loder's number. But now back to Rayos number. Rayos number was actually defined in a big number duel at the MIT, a competition between Augustine Rao and Adam Elgar to write the largest number possible using mathematical notation. The less cool looking Augustine Rao won the battle by defining his number as the smallest number bigger than any finite number named by an expression in the language of set theory with a googol symbols or less. This is the Rayos number. And yes, it is not possible for me to explain this number, so I will put a link of Rayos' interview explaining this number in the description box below, as he can explain it the best. To get some perspective, Rayos' number is so big that even Graham's number looks like a 0 in front of it. Like we don't have words to describe this number. So Rayos' number is the answer to the question in the title of this video. It is the biggest number we know of.